So we're going to finish up the note sheet from Tuesday, because we didn't have school yesterday. Tuesday here. So we're looking at addition and subtraction of rational expressions. And for us to be able to add or subtract rational expressions, we need the denominators to be the same. So the numerators will be the same. We won't mess with them at this point. But we do need to factor the denominators. Now 12x squared is as simplified as it gets. Because we can't factor it, there's no greatest common factor because we only have one term, so we can't really simplify that there. Now our x squared and x do have a greatest common factor of x. And we can factor an x out of both terms, and if we factor an x out of x squared and x, we get x plus 1. So we get this here. Any questions on this so far? Now, we do need to get both of these to be the same, both fractions to be the same, so let's look at the one on the right first. So we have 12x squared. So what is it missing, or kind of what does the one on the right have that the one on the left doesn't? It has the x plus 1, yes? So we need to multiply top and bottom by x plus 1. The only other thing that the one on the right has is the x, but the one on the left has x squared, so we're fine there. Because we don't normally go down, we're not going to reduce x squared to x. We're going to leave it as is. Because the only thing it had extra was the x plus 1. We took care of that. Now let's look the other way. What does the one on the right have that the one on the left have that the one on the right doesn't? So 12. So we're going to multiply top and bottom by 12. Is there anything else? 12x, because the one on the right has x squared, the one on the left just has x. So we'll also need an x on top and bottom. So the one on the right, we're multiplying by 12x over 12x. The one on the left, we're multiplying by x plus 1 over x plus 1. And the numerator, or not numerators, but our denominators, both of them, are going to be 12x squared times x plus 1. So they're both going to be the exact same. Now we're not going to distribute that out because if we did, we'd have to factor it back out. So if there's something in common on top and bottom, we can reduce. Now the numerators, on the other hand, we're going to actually have to distribute this out. So x times 8 is 8x. 1 times 8 is plus 8. The other side's a little bit nicer. 12x times x is 12x squared. Now at this point here, we can go on and just add the numerators together. Luckily with addition, we don't have signs to take care of. So we're just adding them all together. So 12x squared plus 8x plus 8 over 12x squared times x plus 1. Questions on this here so far? Not too bad. Now the numerator, 12x squared, 8x, and 8, is their greatest common factor? 12x squared, 8x, and 8? 4. 4 will go into all three terms. If we factor 4 out of 12x squared, we get 3x squared. Plus, if I factor 4 out of 8x, we have 2x plus 2. Now, the reason we do that is because, well, we need to see if there's any like terms on top and bottom. Well, 4 over 12 will reduce. The 4 will reduce to 1, leaving us with just the 3x squared plus 2x plus 2. But 4 over 12 reduces to 1 over 3. So we get this here. Now the numerator, 3x squared plus 2x plus 2, that won't factor. That's as simplified as it gets. There we go. So there's no way to factor that. So this here is as simplified as it gets. It might be tempting to reduce the 3x squared and 3x squared, but we can't do that because of the 2x plus and plus 2. Because 3x squared plus 2x plus 2 is a term that's not being multiplied. So we can't just break it down that way. Does that make sense? We'd almost have to re-split it back apart into 3 different ones for that to reduce, and it's not making it any simpler. But this here is the final answer. Questions on this here? We ready for the next one? We want to find the difference between these two here. So we have our x plus 2, and we have our negative 2x minus 1. So the first thing we need to do is factor the denominators. Now the first one we can look at factoring is our 2x minus 2. But we can factor a 2 out of both terms. And if we factor a 2 out of 2x, we're left with x minus 2 factored out of 2 is 1. So we get 2 times x minus 1. Now the other one we have is x squared minus 4x plus 3. Since there's not a greatest common factor, we'll have 2 sets of parentheses. Since 3 is positive, our signs are the same and they match the sign of the middle term, which is negative. So we have negative and negative. Factors of x squared are x and x. And the only factors of 3 that we have are 1 and 3. And so we have them factored. Now we need to get the denominators the same by multiplying each fraction by something on top and bottom. So our 2 times x minus 1. What is it missing that x minus 3? Because the other one has x minus 1, x minus 3. Well, it already has the x minus 1. It just needs the x minus 3 to make the denominators the same. What is the one on the right missing? 2. Because they both already have x minus 1. The one on the left now has the 2 x minus 1 and x minus 3. The one on the right is just missing the 2. Now we just need to multiply them together. So the denominators are going to be 2 times x minus 1 times x minus 3. 2 x minus 1, x minus 3. The order in which we write our 2 sets of parentheses, x minus 1 and x minus 3, really doesn't matter as long as we have them both listed. Now the numerators, just like before, we're going to have to distribute this out. So x times x is going to be x squared. X times 2 is plus 2x. Negative 3 times x is negative 3x, and negative 3 times 2 is negative 6. Our other numerator, we're multiplying it by 2. 2 times negative 2x is negative 4x. 2 times negative 1 is negative 2. Any questions on this so far? Now, the next thing we're going to do is kind of 2 steps in one. Now, we do need to combine like terms here, yes? I feel like y'all are comfortable enough, or kind of to a point where you're comfortable enough to do these 2 steps at once. Because one thing we're going to do is combine like terms. 2x minus 3x is negative x. And we're going to make this one fraction. So we're going to combine like terms and put it together. Kind of 2 steps in one. The other way we could have done this is rewrote them as 2 fractions. Just the first one has that combined like terms, and then done this next. really the other one's just going to be minus parentheses negative 4x minus 2. This one we do need to be careful with because addition's not too bad. We're just adding them in. The signs don't change. But when we subtract, the signs are going to change. So the x squared minus x minus 6. We can drop the parentheses. That's fine because the number in front of it is technically positive 1. And multiplying by positive 1 doesn't change the value or the sign. So it's just x squared minus x minus 6. Now the second one we're minusing, because if we minus negative 4x, well, the negative and negative make a plus. So we have positive, yes, positive 4x. Negative, negative 2 is going to be positive 2. So that's what we need to be careful with, especially with subtracting. That negative has to be distributed to the next second term, whichever one we're subtracting from it. And on bottom, we have 2 times x minus 1 times x minus 3. And lastly, we are going to combine like terms. Well, x squared is the only x squared term in the numerator, so we have x squared. Negative x plus 4x is going to be plus 3x. And negative 6 plus 2 is negative 4. Questions on this here so far? Will x squared plus 3x minus 4 factor? Good chance it might. Since the 4 is negative, our signs are opposite. One's positive, one's negative. Factors of x squared are x and x. The factors of 4 are 1 and 4 or 2 and 2. 1 and 4. Which one's positive? Which one's negative? Positive 4, negative 1. Now, it could be the other way, but this is the way I would like it to work. Because if we have x minus 1 as one of the factors, it now has something on common on top and bottom, yes? We have an x minus 1 on top and bottom. Now, we can check this to make sure. Negative x. X times negative 1 is negative x. Positive 4 times positive x is positive 4x, which does give us a positive 3x that we wanted. So those are the ones we want. And we do have something in common on top and bottom that will cancel out, leaving us with x plus 4 over 2 times x minus 3. And that's as simplified as it gets. Questions on this here? How do we feel about this addition subtraction? Not bad. Done worse. Because on a whole, if we try to do the whole addition subtraction all at once, it is a lot, it is complicated. But if we take it one step at a time, factor, multiply both sides and make the denominators the same, and take it one step at a time, it's not that bad. There's a lot of steps, but each individual step is not that bad. Any questions on this here? Y'all need to see another example of one of these here. Yes? I think it would be good. So let's look at this one here. So we can go on and write the two fractions. And set a place for them. We won't put the denominators in yet because we do need to factor those. Because once we factor them, we'll know what we need to multiply them by so that the denominators are the same. So 2x minus 4, I think, is the easier of the two because that is the greatest common factor of 2 that we can factor out. If we factor out 2 out of 2x, we have x minus. Factor 2 out of 4 and we get 2. x squared minus 3x plus 2. Since the 2 is positive, our signs are the same and match the sign of the middle term, negative and negative. Factors of x squared are x and 1 and 2. Yes. Okay, so one of the denominators is x minus 1, x minus 2. The other denominator is 2 times x minus 2. So which one do we want to look at first? Left or right? Left. So the left has x minus 1, x minus 2. What does the right one have that it doesn't? 2. So we're going to multiply top and bottom by 2. Now what is the one on the right missing that the left one has? X minus 1. We don't have to include an x minus 2 because it has one. Since x minus 2 only appears once in the denominator of each one, we only need it once. Since x minus 1 only appears once in any of the denominators, we only need it once. And the same is true for 2. The only reason we would need it more than once is if one of the denominators had it more than once. Now at this point here, we can multiply. So the denominator here would be 2 times x minus 1 times x minus 2. The numerator, we can multiply by 2. 2 times 5x is 10x. 2 times negative 1 is negative 2. Minus. Well, the denominator is going to be 2 times x minus 1 times x minus 2. We can distribute across the numerator. Negative 2x times x is going to be negative 2x squared. Negative 2x times negative 1 is going to be plus 2x. Negative 1 times x is negative x. And lastly, negative 1 times negative 1 is plus 1. Questions on this so far? We good with this here? Yes. Now, if y'all were comfortable with the 2 and 1 step that we did last time, we can do it here again. Let's scroll back up. Because we can put parentheses 10x minus 2 minus. Because we put the parentheses around it, we don't necessarily need it for this one because there's a plus, there's positive in front of it. So it's still going to be 10x minus 2. Nothing's going to change there. However, everything in this second numerator is going to change because of the negative in front of it. So we say minus parentheses. Now we can combine like terms, negative 2x squared. 2x minus x is plus x plus 1 over 2 times x minus 1 times x minus 2. I think we feel comfortable doing that, yes? Because the alternative is just, I'll write it out here to the side, just saying 10x minus 2 over 2 times x minus 1 times x minus 2 minus negative 2x squared plus x plus 1 over 2 times x minus 1 times x minus 2, and then going down to this here. All I did was essentially rewrite it and combine those two middle terms, and then just moved it together. Y'all kind of see that? If you all feel comfortable merging them and combining those two terms, there's nothing wrong with that. But if that's a lot, we can always go step by step. All right. We can drop our parentheses. Now the second one, we do need to distribute that negative through. Negative 2x and be plus 2x squared. Negative with positive x and be minus x. And negative with positive 1 is negative 1. Make sure. Yep. At this point, we can combine like terms. 2x squared is the only like term with it. 10x minus x is going to be plus 9x. must be. Yep, that is -2 minus 1 is -3. And that there is as simplified as it gets. Like I had a sign difference and got a 1 instead of 3 last hour. Questions on this here? Now I went on and circled it mainly because there's no way the 2x squared plus 9x minus 3 is going to factor. That is as simplified as it gets. Any other questions on any of this here? We feel a little bit better with this for the most part. Well, we're going to do one more, and that's this one here. So all the way at the back, right before the homework page, it is the last problem in the notes. It's this one here. Now this one, I'm already going to write the spaces for what we multiply, because if we don't, we won't have room for the middle one. Now the numerators for all three are going to stay the same. X minus 2, we can go on and fill it back in. 2 and 4x. Now the denominator for x minus 4 and x are going to stay the same, mainly because x minus 4, there's no greatest common factor. There's no way we can factor it. It's already as simplified as it gets. Same thing's true for x. Now the x squared minus 16 is factorable, because we do have two terms being subtracted. X squared is a perfect square, it's x and x. 16 is a perfect square, it is 4 and 4. So we have x minus 4 and x plus 4. So it doesn't really matter which one we start with, but we do know that each one of these denominators is going to need an x minus 4, yes? First one has an x minus 4, the middle one just has x, so it will need an x minus 4 on top and bottom. And the last one has one. We also know each one's going to need an what? X plus 4. Well, the middle one is missing the x plus 4, and so is the first one. Is there anything else that these three denominators are missing? X. The middle one has x, so the one on the far right needs it, and the one on the far left needs an x over x. So the first fraction is being multiplied top and bottom by x times x plus 4. The middle one is being multiplied by x minus 4 and x plus 4. And the last one's being multiplied by x. And we multiply the denominators together, we get x times x minus 4 times x plus 4. Plus x times x minus 4 times x plus 4. Minus x times x minus 4 times x plus 4. Now, one of the easiest ones to multiply with the numerators out of all of them, I think is the last one. 4x times x is 4x squared. That's quite nice, quite easy to do. We'll do the middle one next, 2. So we're multiplying x minus 4 and x plus 4 together, yes? Where did we actually get those two factors from? We got them from where? X squared minus 16, yes? So if they factored from x squared minus 16, and we got x minus 4 and x plus 4, if I multiply those two back together, what should I get? X squared minus 16, yes? And with this chapter, if we end up getting two things multiplied together that we factored from a polynomial before, we could multiply it out. I can do x times x times 4, negative 4 times x, and negative 4 times 4. I can just say it's x squared minus 16. Because if we factored it from something above, we're definitely going to multiply back together to get that. Does that make sense? I mean, it's just using the resources that we have. There's no reason to multiply it out if we factored it from something above and already know what that's going to be. Now the last one, last numerator, x. We're going to have to multiply x plus 4 by x plus 2. We didn't have it above, so we're going to have to multiply this here. Well, x times x is x squared. X times negative 2 is negative 2x. 4 times x is going to be plus 4x. And lastly, 4 times negative 2 is negative 8. Questions on this so far? Now, we can do this one step at a time, but I think y'all are running about halfway through the space that you already have. Yes? So we're not going to rewrite this over and over again because then you'll completely run out of space. But we are going to eventually put this all together as one, yes? Now, the first one, we'll do some simplifying in this step too. We have x times, we have x squared, negative 2x plus 4x is plus 2x minus 8. So let's go on and combine those two. Plus 2 times x squared minus 16 minus 4x squared. And so over x times x minus 4 times x plus 4. Right there. Okay. Now we can simplify these parentheses and then combine like terms. So for the first one, we're going to need to distribute the x across all three. X times x squared is x cubed. X times 2x is plus 2x squared. X times negative 8 is negative 8x. Positive 2 times x squared is plus 2x squared. Positive 2 times negative 16 is negative 32. And lastly, the negative times 4x squared is negative 4x squared. Over x times x minus 4 times x plus 4. Might need to give you all a second to catch up. And again, if I get going too fast and you're a step or two behind with copying things down or follow along, tell me. I'll slow down, I'll stop, let y'all catch up. Last thing we need to do is combine like terms. So we can start with the one with the biggest exponent, x cubed. Well, x to the third, there's only one of them. So we can rewrite that there. Next one we look at is x squared. We have 2x squared plus 2x squared is 4x squared minus 4x squared is 0. 4 minus 4, 0. So those cancel each other out. They're gone. So x to the first, well, we have negative 8x because there's only one of them. And lastly, we have minus 32. And I believe that is as simplified as it gets. Because x cubed minus 8x minus 32, I don't see it factoring. So I believe that is as simplified as it goes. So your homework is on page 392, 4 through 6, 8, 12 through 14, 20 through 23, and 26.